So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we are going to consider these 10 JAMB repeated questions here on the topic atomic structure, electron configuration, atomic number, and mass number. So guys, in short, stay till the end of this video as this is a very important one. So at any point, if you feel you want to answer the question before we provide the answer, you can always pause the video and try to see if you can answer the question even before we provide the answer thereafter. So guys, without wasting much of your time, let's start with the first question here, and that's question number 1. So the question says 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. An element with this electronic configuration is A non-metal, B transition element, C group 2 element, D metal. So guys, the answer to this question is option B, and that's transition element. So guys, this is a transition element because here this element is actually a D block element actually. So you know that D block elements are actually transition elements. So particularly this is the electronic configuration for cobalt. So guys, that's for that question. Let's consider the next question. That's question number 2. It says, how is atomic mass expressed on the periodic table? A, as a decimal number relative to carbon 12. B, as the sum of protons and neutrons in the nucleus. C, as the average mass of all atoms in a sample of the elements. D, as the mass of the most abundant isotope of the elements. So guys, the answer to this question is option A, and that's as a decimal number relative to carbon 12. Let's take, for instance, the atomic mass of oxygen is approximately 16.00 atomic mass units. So this indicates that an average oxygen atom is about 16 times heavier than 1/12 of the mass of carbon 12 atom. So guys, that's how atoms or atomic masses are expressed on the periodic table. So let's consider the next question, guys. Question number 3. It says, which of the following orbitals of carbon are mixed with hydrogen in methane? A, 1s and 2p. B, 2s and 2p. C, 2s and 3p. 1p and 2s. So guys, the answer to this question is option B, and that's 2s and 2p. So the orbitals of carbon that are mixed with hydrogen in methane are the 2s and 2p orbitals. So this is because carbon is actually in the second period of the periodic table. So it uses the second shell, which has the 2s and 2p orbitals for bonding. So guys, that's the answer to this question, and that's option B. So let's consider the next question, question number 4. We have here an equation of a reaction. So we have the chlorine gas here plus 1 electron to yield a chloride ion. So we also have the change in enthalpy to be negative 365 kilojoules per mole. So guys, the question here says change in enthalpy in this equation above represents A, heat of atomization. B, electron affinity. C, ionization energy. And D, dissociation energy. So guys, the delta H here actually is the electron affinity. So the electron affinity is the energy released when 1 mole of electrons are added to 1 mole of gaseous atom to form 1 mole of the corresponding anions in the gas phase. So guys, that's the answer to this question here. That's electron affinity, option B. So let's consider the next question, question number 5. The question here says the oxidation state of chromium in potassium heptaisochromate 6 is A 4, B +5, C +6, and D +7. So guys, in order for us to get the oxidation state of chromium here, we're just simply going to make a quick calculation here. So guys, over here, let's zoom into our workspace here. So over here we have potassium heptaisochromate here. So guys, the first thing we are going to do here in order to get the oxidation state of chromium here, we are going to find the valence of the other elements here. So the valence of potassium is actually +1, so that's +1, and it is by 2 here, so we are going to multiply it by 2, then plus, so we are looking for the oxidation state of chromium here multiplied by 2, and then plus the oxidation state of oxygen here is actually -2, then multiplied by 7. You know that the valence of oxygen is -2, so that's -2 multiplied by 7 here, and we're going to equate this to 0. So 2 times 1 here will be 2, plus 2 times chromium will be 2Cr here, and plus 2 times -2 times 7 will be a -14 here. So this will be equal to 0. So having gotten this, we are going to actually collect the like terms here. So this will be 2Cr is equal to 0 plus 14 minus 2, and then 2Cr is going to be 12, and then Cr is going to be 12 over 2, and guys, that's 6 here. So the oxidation state of chromium is +6. So guys, that's the answer to this question, and that's option C here. So guys, the oxidation state of chromium in this chemical compound here is +6. So that's why we name this compound as potassium heptaisochromate 6. So guys, that's the answer to this question. So let's consider the next question. That's question number 6. It says the colored nature of transition metal ions are associated with their partially filled A, D orbitals, B, S orbitals, C, F orbitals, D, P orbitals. So guys, the answer to this question is option A, and that's D orbitals. The colored nature of transition metal is actually associated with their partially filled D orbitals. So this is because the D orbitals of transition metals can absorb certain wavelengths of light. So this will result in the color we see in these metals. So let's go ahead and consider the next question. That's question number 7. The electronic configuration of magnesium ion here is A, 1s2, 2s2, 2p6, 3s2. B, 1s2, 2s2, 2p6, 3s2, 3p2. C, 1s2, 2s2, 2p4. D, 1s2, 2s2, 2p6. So guys, we know that magnesium has 12 electrons, guys. So in this case, we are looking at magnesium ion. So let's just quickly zoom into our workspace here. So we know that magnesium has 12 electrons. So magnesium ion actually signifies that it lost 2 electrons. So in that case, magnesium ion will have 10 electrons. So having known that, now let's solve for this. We'll have 1s2, that's 2 electrons already. Then 2s2, making 4 electrons. And then 2p6, making 10 electrons. So that, guys, this is the configuration for this magnesium. So magnesium ion will have 1s2, 2s2, and 2p6. So guys, option D is the answer to this question. So that's 1s2, 2s2, and 2p6. So guys, let's quickly consider the next question here. That's question number 8. So question number 8 says, an oxide XO2 has a vapor density of 32. What is the atomic mass of X? Take O to be 16. So guys, we have here option A, 20, option B, 32, option C, 12, and option D, 14. So guys, we need to understand that the vapor density is actually half of the molecular mass. So the molecular mass of an element over 2 is the vapor density. So guys, let's just zoom into our workspace here and solve. So we are given the vapor density already to be 32. So it means that the molecular mass over 2 is equal to this vapor density. And guys, how do we get the molecular mass from here? So in order to calculate for the molecular mass, we have X, then plus O2. So oxygen is 16, then times 2. Then this will be over 2. So guys, with this, we have that 32, we are going to cross this. So we have 32 times 2 is 64. So 64 is equal to X plus 16 times 2 is 32. So guys, finally X is going to be 64 minus 32. So finally X is equal to 32. So guys, the answer to this question is option B, and that's 32. So we'll go ahead and consider the next question, guys, and that's question number 9. Question number 9 says, an element Z contains 80% of Z. So Z here has an atomic mass of 16 and atomic number of 8, and 20% of another Z having an atomic mass of 18 an atomic number of 8. So guys, its relative atomic mass is, so we are going to consider the relative atomic mass. So this is more like an isotope. So we are going to consider the relative atomic mass here. Option A is 17.6, option B 16.4, option C 16.2, and option D 16.0. So guys, in order for us to get the relative atomic mass, let's quickly zoom into our workspace here. So let's bring up our calculator. So here's our calculator here. So the relative atomic mass here is going to be, since we have the one with the atomic mass of 16 to be 80%, it means times 80%, then plus the one with 18 is just 20% in abundance. So it means the 18 times 20%. So guys, let's quickly use our calculator to solve this out. So 16 times 80 over 100, that's 12.8, then plus 18 times 20 over 100, that's 3.6. So guys, if we add these two, we're going to get 16.4. So that's 16.4. So guys, that's the answer to this question. And guys, here, that's the option B. So that's it for that question, guys. Let's go ahead and wipe this. So we're going to consider the next question, guys. And that's the last question for this. So if you're new to subscriber to this channel, guys, please go ahead and hit the subscribe button to get updates when we post new videos. So guys, let's consider this last question. Chlorine consisting of two isotopes of mass numbers 35 and 37 in the ratio 3:1 has an atomic mass of 35.5. Calculate the relative abundance of the isotope of mass number 37. Alright, so guys, let's go ahead and zoom into our workspace here, and then let's go ahead and get our calculator down here. So we're going to, first of all, we're going to state out and chlorine 37. So this is chlorine 37, then this is chlorine 35. So guys, having these two, guys, we are going to, so let's say the relative abundance of chlorine 37 is X. So if we're taking the relative abundance of chlorine 37 to be X, which is an unknown, we know that relative abundance of chlorine 37, which is X over 100 times 37, then plus the relative abundance of chlorine 35, which is going to be 100 minus X so in this case over 100 times 35 will be equal to 35.5, which is the average atomic mass of the chlorine here. So guys, if we have this way, so you know why we have 100 minus x here, because everything here should sum up to 100. So the value here and the value here should sum up to 100. So that's why we have this. Okay, so guys, the next thing we are going to do here is to multiply out. So we are going to have 37x here over 100, then plus 35 times 100 is 3500, minus 35 times x is 35x, so over 100, and this is equal to 35.5. So guys, to remove the denominators here, we're going to multiply the numerator by 100. So in that way, if we multiply out by 100, we're going to have 37x plus 3500 minus 35x equals 100 times 35.5, so 35.5 times 100 will be 3550. So guys, at this point now, we are going to collect like terms, and that's 37x minus 35x is equal to 3550 minus 3500. So guys, at this point, 37 minus 35 is 2, so 2x is equal to 3550 minus 3500. So let's go ahead and check this out here. This minus 3500, that's 50. So 2x is equal to 50. So guys, let's go ahead and wipe here. So guys, if 2x is equal to 50, then x is equal to 50 over 2, and that's 25. So guys, the relative abundance of chlorine 37 is 85. So chlorine 37 has a relative abundance of 25%. So guys, that's the answer to this question, and guys, that's option D. So guys, this will be the end of this video. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to our channel if you're not a subscriber. Also guys, if you have any question regarding this video, please drop your question on the comment section below, and we'll ensure to give you a response. Also, we encourage you to join our channel membership to get premium information on JAMB updates, guys. So you're going to definitely enjoy this when you do that. We'll love to see you there. Thank you for watching this video, and see you next time.